All right, before we get started, the audio people have asked me to ask everyone to silence their cell phones. Oh, that's right. Hang on. Yeah, I hadn't done it either. But all right, so we've got our slide up there. As you see, this is the classic game Postmortem for Pitfall, as it says out there on the sign. The average age here looks a little higher than most of the seminars here at GDC, so maybe some of you have actually seen this game or played it. It was the hottest selling game in the 1980s. It spent 64 weeks on the number one bestseller list, at number one. But I'm going to assume that some people here haven't seen it or don't exactly know the inner workings of the Atari 2600 or that sort of thing. So if I'm going to try to explain how I came up with Pitfall, I'm going to have to get pretty deep into what the Atari 2600 was all about so that you can kind of understand where it came from. So basically, the sign also out there identifies me. I'll give you a little bio information. I started in the video game business at Atari, working with Nolan Bushnell, right about the time he was being corporatized out. But still, it was a lot of fun to work with Nolan. And once he left, the place kind of fell apart, and a few of my friends and I left Atari to found Activision. And the founding principle from Activision was to get recognized as authors of a creative work rather than just nerds in the back room. And the real impetus was when we had this discussion with the CEO of Atari, and they said that we were no more important to the game than the person on the assembly line who put it together, because without them, we couldn't sell any games either. So we started Activision under the premise of being treated as authors, getting some sort of a recognition for our work. And in doing so, we started the first third-party developer of video game cartridge software in history. That started something pretty big, which is what we see out here, is most of the companies that you see here at GDC are independent publishers, or certainly they don't make their own hardware. There's only a few companies that make those anymore. So that's what the third-party business is. And that was a lot of fun. Gotten a few awards. This is nice. I continue to work on video games every day of my life. I've been doing it for 34 years. I've published over 80 products. I've worked on every console ever made. Once did a count, and I've programmed games in 15 different languages for who knows how many consoles and systems and microprocessors and processors. And so what you're looking at in front of you here is, if you enjoy your job, this is something to look forward to. You can still be doing it in 34 years. If you hate your job, then you could still be doing it in 34 years. But, so the real question is, how did that guy make that game on that machine? And yeah, that was me when I was working on Pitfall. I was 25, 26, I don't know. And as you can tell, I wasn't having any fun. Think of the Atari 2600 as a CPU with a video card and a sound card. I mean, it's very similar to what we're doing today. Inside was a microprocessor and a piece of hardware. And that hardware was just an engineering chip that was in the microprocessor's CPU's address space. So if I wrote an 8-bit number to a particular address, I could change the color of the background of the screen. If I wrote a different number somewhere else, I could make a tone happen. Another number, 4-bit number as it turns out, I could set the volume of that tone. So really the CPU was running along and just slaving this device, and if you did it right, certain things would show up on the TV screen. I believe it was the first to use a microprocessor. There was another one, the Fairchild Channel F, was happening about the same time, but I'm going to give Atari the nod for that. And so if you set out to design a game for this hardware, you almost had to think in hardware rather than software. You had to be thinking, I have to send this value to that register to do this. There were no high-level languages used. It was all done in assembly language, counting cycles, counting bytes. It was an interesting challenge. In detail, the Atari 2600, the screen was 160 pixels wide, not 1024 by 768. It's 160. And it's not by anything. It's 160 pixels. That's all the thing could display. And basically, you set up those 160 pixels, and then before the TV scan came around to show them again, you changed them. And you had to change the pixels, that row of pixels, every scan line as the TV scanned. Get into that a little more later. The system had 128 bytes of RAM, and that's total bytes. And you shared that with your CPU stack. So if you decided to do a subroutine call, you lost a couple bytes of that. So we tried to allocate 4 bytes for that and never go deeper than 2 levels of subroutine. The cartridge was a 4K byte ROM, and that was double what we had when we started at Atari. They started springing for 4K bytes by the time I got to Pitfall. 6502 microprocessor, called a 6507 because they made it cheaper by putting it in a smaller package and leaving some of the address lines out. Address lines we really wanted to use but couldn't. They had never left the chip. And in that 160 pixels that the 2600 could display, there were really just 5 objects. 2 8-bit registers and 3 1-bit registers. And all that register knew how to do was to clock its 8 pixels out at a particular spot, or starting at a particular spot on those 160 lines, 160 pixels. There was also a low-resolution playfield block system that it was 4 pixels per square, and it's effectively 40 across, although they cheated us by taking half the registers out, and it was really only 20 bits. And you could use them, again, on the second half of the screen, either reflected or repeated. But the CPU is doing everything. The CPU is building the screen as you see it. It's not thinking about game logic. It's not reading the joysticks. It's not trying to decide what to do next. It is continually busy building this screen. And at the end of that, while the trace is in vertical blank and retrace, you had about 25% of your CPU time left to do all of your game calculations. So I call this a shameless plug because I didn't want to see some of this technology lost to the world. So I wrote a couple iPhone apps for if anybody who is interested in how this sort of thing works. All that information is actually available on the internet. But I tried to bring in some people even less technical, and I used animated figures and tried to explain exactly how this whole thing works. And I bring it up here simply because I'm going to use some of the screens from it, and I didn't create the screens anew, I just stole them from my own work, I guess. So as I was saying, does this mouse show up here? Yeah. This is a TV tube. Now, if this was an LCD, you would have 1024 by 768 pixels, and those pixels just exist. Well, with a tube, there was an electron beam scanning along at a particular speed. Then it would turn off the beam and retrace back to here, turn on the beam, and scan it like that, so that when you pulsed the beam on and off, you could turn pixels on and off. So this is all happening in real time. An entire picture is painted 60 times a second. Each one of those, the frequency of this red thing we see here is about 15 kilohertz. So the Atari engineers knew how the TV worked, and they synchronized the hardware to that TV scan. And you don't have to read this even if you can, but it just kind of shows if we're looking at this thing is 160 pixels across, we can't really even turn on every pixel. We can turn on these 8 and 8 more somewhere else, and 3 1-bit objects. That's all that we could have, except for that blocky playfield, on a single scan line. Every game that you've seen for the 2600 was made by just turning on a few pixels on each scan line intelligently. If you're writing the code well enough, you can take a little extra time during that time and write colors to the pixels and change them, and we came up with all sorts of different enhancements as time went by. That's just a little better view of it. The next time that the scan comes around, if I have changed the graphics by clocking it out of that ROM, I now have a different image on every scan line. And then just choose a different spot in the ROM, and that's the other tank. So we're going through this pretty quickly. Again, if you really want to get deeply into this, there are other places to do it, but I can't be talking about Pitfall unless people have at least a rudimentary understanding of what the 2600 did. So a typical game on the 2600 is this. Here's the blocky playfield we were talking about, and then this is one 8-bit object, and this is one 8-bit object, and when they shoot the 1-bit objects that I was talking about. And that's really what this game was designed to do, is this game. And then they added a ball object so that they could also do Pong. So seriously, the engineers at Atari designed the 2600 to be cartridge programmable so that they could sell you a tank cartridge and a Pong cartridge. And if anything else came out of it, they were really happy. So you see, if you're running this code synchronous with the scan line, you have to output nothing where you don't want any object, output the graphics out of the ROM where you do, and then output more nothing. The original games, this was all one loop. Later, we would break into different loops so that you don't have to output nothing if you've output nothing once, and you don't need to output something other than nothing for a while. Then one of the first enhancements here was, this is very similar. At the bottom, you've got the 2 players, each one making a little cannon. But in the bands in between, one of the player objects is used to make a jet, and then it's repositioned to make another jet, and another jet, and another jet. And so you can see, if you're programming in bands like this, you can now, an object or a machine that puts out 2 objects now has 8 or 10 objects on it. And that's pretty much the key to everything that we had to do. Then there's the little missile as well. Now Pitfall, we'll get into Pitfall now. I've told this story several thousand times because people ask me, how did you create Pitfall? And I didn't want to make every game I did out of jets and airplanes and tanks and things. I really liked the idea of trying to get an animated character into a game. So I would walk around the design lab and freeze in one position and then sketch the position of my feet. I was doing kind of the animator thing. And I would go to these pixels and I would fill in the pixels and try to decide if I could make something walk or run. And I had done a pretty nice looking little running man 2 years before I even started Pitfall. But every time I sat down to think of a game to do it with, or to make out of it, nothing came to mind, and I kind of put it on the shelf, and I went off and I did another space game or another sports game or whatever. So I sat down at one point and I said, I'm not getting up until I have designed a game to use this little running man. And I literally sat down there with a blank sheet of paper, and I drew a little running man. Looked at it, and I said, all right, he's running. Well, let's give him a path to run on. And drew 2 lines, and it was a path. Where is the path? Well, let's put the path through a jungle. Why is he running? He's escaping obstacles. He's collecting treasures. At a subterranean level, make it a little harder to travel there because of the scorpion. Add the scorpions and the crocodiles and treasures to collect and that sort of thing. And literally, in 10 minutes maybe max, I had the design document. Okay. Well, that's it. That's the design document. And it's about the most design document we would ever do back in those days. Because we couldn't just say, I want a helicopter, or I want, the ocean. You had to say, all right, what can the Atari 2600 do? And based on what it can do, what do I want? So, again, we never got any further than that on design concept. So there we were in 10 minutes. That led to about 1,000 hours of programming to make it happen on the Atari 2600. In that day, one man, one game. Thanks to Carol Shaw, there was a woman. And there were a couple women game designers back in that era. But it was mostly about 50 to 100 guys doing this, nerds like us. Like me. There were no art tools. We would literally take a piece of graph paper and color in squares and hold it out and say, looks like a guy to me, And then we would have to actually write down the binary codes and enter them one at a time into the ROM so that it would look like that when we're done. The sprites were mostly monochrome. You saw in the two tanks, one was red and one was yellow to represent the player colors. That's because I can change the player color, but if I want to make a character like Pitfall Harry that's standing there on that graph paper, not only do I have to change his graphics on every single scan line of the television, I have to change his color, which takes more time, and you only have so many processing cycles going on before the beam comes around again. So there was a lot of tricks we had to pull to make the things look like they did. We also, for sound effects, we could make a white noise, we could make a square wave, and we could make a sine wave. Well, actually, it was a triangle wave. And with those running algorithms, we can make a sound. Excuse me. So if I wanted to have a siren, I had to set the tone to be the triangle wave. I had to set its frequency into some sort of a sinusoidal ramp and vary its volume if I wanted to have a warble to it. Actually, I had to write a piece of code that took the hardware, again, by just shoving data into registers, and make it do what I wanted to do. So you counted every CPU cycle because as the scan was moving, so was the CPU clock. And for every 3 of those 160 pixels, you had 1 microprocessor cycle. You can't do anything in 1 microprocessor cycle. The minimum is 2, sometimes 3, sometimes 5. So 15 pixels have gone by before you do a single 5-cycle instruction. There's not a lot of time to be messing around up there changing these bits. And it had to go into ROM, so we counted every single byte. Sometimes we would be at 6K when we were ready to be done with a 4K game. Now you have to go back and rewrite every single line of the game, rewrite an algorithm, and say, I did it, and I did it in 3 less bytes. So I saved 3 out of 30. We would have people, you'd see graphics on the screen that was actually code because it was easier to do that. Sometimes we would have graphic tables that ended in a byte that was an opcode that we could use as the end of a routine. Anything to get 1 byte out of the whole thing. Built our own ROM emulators to plug into the 2600, wrote our own debugging software to be able to set breakpoints and such. This was everything we had to do to make one of these lousy games. Now, did I say that? There, as I said, there's a lot of resources on the web and such, but I'm going to plug a book that anybody who has any interest in this should buy this book. If you look at the description, it is a planned series of text, and the premise is that if you design a game for a particular platform, the capabilities and limitations of that platform are going to affect the game. And a couple guys decided they wanted to study that and look into it. In fact, one of the authors is here. Ian, you still over there? Yeah. Wave your hand. But It is a very thorough study on what we had to do in those days and explains how the limitations could affect the game itself. Here's a diagram from the book that helps explain a little bit about Pitfall. So I showed you combat, or tank, where it was really one loop with two players, two tanks, one missile each, and some background. By the time we got to games like Pitfall, every one of these little dotted lines is a different loop. We write an entire program loop that outputs your 6-digit score. Then I modified it a little bit to put your lives up here. Those are the missiles, actually turned on and left on for the height of a number. Then turn everything off, and then use a background color for the tops of the trees. In here, you'll see I used some of that blocky playfield to try to make the canopy of the tree. And to make it a little more realistic, I used the player objects as branches. At the end of that, turned on the pattern for the tree trunks. Down here began outputting the objects and Pitfall Harry himself. Pitfall Harry doesn't have to be up here, ever. So I'm able to use his player object up here for tree trunks, or for tree branches. Pitfall Harry doesn't have to be down here, so I'm able to use all the sprite objects. The missile, or the vine, is one of the 1-bit objects, moved every couple scan lines 1 pixel or another to make that swinging vine. And fortunately, there's a little bit of the hardware on the 2600 that this is one player object, but it can be repeated 3 times. Excuse me. The graphics have to be exactly the same, but it's kind of nice because it allows you to put what looks like multiple objects on the screen. That's done up here too. This is a repeated copy of that same thing. So anyway, once I had a world, I had this other problem, and that is, how do I create a world where every screen is unique, every screen is different? I've got 4K bytes, which in total would do, a hundredth of a JPEG. I mean, in total, for all the programming, all the graphics, it has to also define the entire world. So I came up with kind of a cool trick on this one. This one I've always been proud of. There's an animal called a polynomial counter, and it's basically, think of it as an 8-bit counter that doesn't count up sequentially. It counts in what looks like a pseudo-random number sequence. And we use those a lot to create random numbers. Anytime we wanted to put something random in the game, have a random event, we would use this polynomial counter and just let it count continuously and then snapshot it. And I might snapshot it and it would be one number. I snapshot it would be a completely different number. Well, I wrote a polynomial counter that was reversible. What that means is if you incremented it, it would go from, say, 12 to 93 in this pseudo-random sequence. And then if you decremented it, it could go back from 93 back to 12, which was kind of tricky. It was hard to do. But once I did it, I said, well, this is great. All I have to do is when Pitfall Harry runs off the right side of the screen, I increment it. And then when he runs off the left side of the screen, I decrement it. And now I've got a sequence of numbers that are 255 long in sequence. And it makes this circular world. And it's always repeatable. So then I take that 8-bit polynomial counter, and I take 3 bits of it for the path object, 3 bits of it for the shape of the middle, whether it's 1 hole, 2 holes, water, tar, with or without a vine, that sort of thing, and make 4 different tree patterns so that when you moved across the screen, the trees changed a little bit, so it told your mind that, gee, I must be on a different screen because the trees moved. And where the brick walls are in the underground passage and that sort of thing. So the polynomial counter itself was about, 16, 17 bytes to generate. And then from that, I chose different graphic elements for the world, such as for that area in the middle, I decided, one hole with a ladder, 2 holes or 3 holes with a ladder, and the various ponds, pits, or tar pits, plus whether or not they had alligators in them, whether or not they expanded and contracted, which we ended up calling quicksand, and in fact whether they had a vine over them to allow you to swing across. All pits had vines unless they either collapsed so that you could run past them, or they had alligators that you could run across. And I could even go a little farther back in time, before anybody's time, to where the inspiration for those alligators came from. Back in must have been the 50s, because when I saw them, they were old already. It was a series of cartoons with the cartoon characters Heckle and Jekyll. And in their intro for this cartoon, these were magpies, whatever a magpie is. I mean, why you choose a magpie as your main character, I don't know. But and they would run across the heads of alligators as they're snapping closed and barely escape with their lives. And it just popped into my head. I mean, we take inspiration from anywhere. And I said, all right, let's run across the heads of alligators in this adventure game we're creating. So 1,000 hours of that, put it in the ROMs, send it off to be manufactured, bring it back, sell it in the stores, and Pitfall became pretty successful. Activision eventually put out a map of the world. The trick of going above ground and below ground was necessary to complete the game. So some people had a little trouble, and we eventually showed where you want to take the shortcuts. But we had hundreds, if not thousands, of people sending in their own maps. As you can see on the right there, some guy who's playing it and draws the whole thing and maps the entire world so that he can play the game. And in that era also, where these maps were coming from, at one time, Pitfall was receiving 14,000 fan letters a week. And we had a staff of 7 or 8 people just working full-time, opening every single letter, which is how we got some of these submissions. A lot of people always ask me for neat tricks when it comes to the 2600. You saw the polynomial world. Well, the thing about the polynomial world is the polynomial defines the world. Here I am, the game designer, and this 8-bit thing is defining the world. So it decided where there's a pond and where there's alligators and where there's a vine. So I had to look at all 255 screens and analyze them from the standpoint of where's the good gameplay. And I found a spot way out in the polynomial count, which of course I could seed at any point. I could just pick any random number to seed. So I seeded out there at 113 or wherever it is. And that's the game that you have today. And my planning there was to teach people the skills they need to learn for later screens on easier screens. So first you had to learn that when you move the joystick to the left or right, you run. Then you learn you can jump. You learn you can jump while running. Pretty soon you're going to have to learn to jump from a standing start. And all of those skills, if I placed you right on the middle alligator, for example, you wouldn't have enjoyed the game. You had to learn the skill as you went, something that we liked to do in those days. We didn't like people to have to rely on a manual for the game. You pick it up and you start to play, and we gently lead you into the more difficult things. So even though the world was built on that polynomial, there was some game design in there, trying to figure out how to best present it to the user. The swinging vine, I mentioned it's a 1-bit object. Basically, during the time I'm running the display loop for that object, I am computing its angle. And I'm doing that by accumulating an 8-bit number that wraps over, and every time it wraps, I bump the position of the object. So it's kind of unusual to have the display code actually running an iterative process to decide what to display next. But that was going on in the vine. The trick with the underground shortcut, I made it so that when you left the right side of the screen, if you were underground, it would increment the counter 3 times. Very simple. You skipped over 3 above ground screens, making it a shortcut. So why not just play the whole game underground? Well, I tried to make the Scorpion really hard to jump over. I mean, if you wanted to take the shortcut, you better be pretty good at jumping. Plus, I threw some brick walls in there every once in a while, so you can't just do that. You have to go back, go up, go around, and try to collect all the treasures. Jumping laterally was actually kind of an interesting thing. The 2600 displays the entire screen, as we said, and then there's 25% of the processing left over to decide what to do for the game. So I'm reading the joystick, making the calculations at the rate of 60 times a second. And if you try with a joystick to move to the right and push the jump button in the same 60th of a second, it's not going to happen. Basically, when I first started doing it, I was just falling into the pit with the alligators every single time. And it just, every once in a while you'd get it and you'd say, yeah, but that's just too hard. So I tweaked that so that you could add direction to your jump in the first 3/60ths of a second of your jump. Basically tweaking it so it's not so easy. I really hated the idea of being able to jump and then move while your feet are off the ground. I'm just a stickler. I like physics. But when I gave you just that little extra window of saying, oh, that's what you meant. You meant to go to the right. You meant to jump laterally. So there's actually code in Pitfall very carefully helping you to make that jump from one alligator to the other. When I finished the game, I handed it off to my buddies and I said, I'm done. And I said, I've decided that you only get one life to play this game. Isn't that going to be cool? You play this one game, it takes 20 minutes, but if you die 17 minutes out, that's it, you're dead. Wouldn't that be nice? And they beat me into submission. And so I said, oh, you mean now I got to put in lives? I've already done all of that code reduction, stealing bytes here, tying into subroutines into tables. I've done all that kind of stuff. And now I have to do an entirely new thing, which is when you die, I have to be able to spawn a new life. I have to be able to display those 2 tick marks up there to show. So I had to go through another 2-week code reduction session to get enough bytes to be able to put that in. But I'm glad I did. I would probably be getting 14,000 letters of hate mail a month if I hadn't. And a little display here on the bottom of this one is Pitfall Harry's feet. If you ever see Pitfall Harry falling into the water, he goes into the water. I mean, it's pretty cool. You know, you don't see his feet through the water. Well, if you look at that little display, the path is actually 2 more of those loops where Pitfall Harry is always above the middle when he's running around, if you look closely. And if I ever tried to move him below the middle, his feet would disappear. Because in the bottom half of that loop, I don't write his graphics. So the other objects, like the alligators, are written through the entire 16 pixel or 16 scan lines. But Harry stops in the middle. That's also the point at which I vertically reflect the path. If you'll notice everything on the path is vertically reflected there because it saved bytes in the ROM. But it just gave me what I needed without having to go to a lot of trouble. In other words, he goes through the water correctly because I stopped writing him, not because I went to a lot of trouble to make it happen. Anyway, it's kind of cool. Pitfall was pretty successful. We have a number of other products showed up. There was a board game. There were coloring books, puzzles. It actually spawned a Saturday morning cartoon show. And if anybody has any of those recorded, I would love to be able to see them again. They're not on YouTube. They're gone forever, unless some collector has them. Let me know if you do. And all sorts of other things. I loved that crocheted television with Pitfall screen on it when I first saw it. The pith helmet and jacket was a giveaway at one of our parties for Pitfall. Just all this cool stuff. Plus, some of you do remember that the patches that Activision gave out in the 80s were the first achievements. The first, Now you collect them virtually. We actually mailed them to people. Again, it was very successful. Lots of cool stuff. For any of you interested in this who haven't heard of this, there is a trade show in Las Vegas every year called the Classic Gaming Expo. And the guys who run that, it's a labor of love. They transport a ballroom this size of a museum. And it's every single thing ever done in the classic video game era. They have every piece of hardware, every piece of software, every ROM cartridge, every one of these print ads, everything that ever was made, they have one of them. And I highly recommend going to that if you have any interest in classic gaming, just to see that museum. It is astounding. And we also did some television commercials. I'm going to run this twice. The first time, just so you can see it.
Just last night, I was lost in the jungle with Pitfall Harry, surrounded by giant scorpions and man-eating crocodiles.
Well, Harry and I just grabbed the van, swung through the trees, and over the tar pits and found the jungle treasure. It was really neat.
If you haven't met Pitfall Harry, you're missing the year's most incredible video game adventure. Pitfall for the Atari 2600 and in television.
Since I met Pitfall Harry, no other man will do.
Pitfall, designed by David Crane for Activision.
Now, you chuckle at that ending, but I told you that one of the founding principles of Activision was to give the designers some credit in a video game. And we were the first to do that, and it is stuck. But we were accused of wanting to be rock stars when we did that. They said, oh, you guys just want to be rock stars, you want to be recognized on the street and that sort of thing. And I saw that commercial and I said, you're right. I do get recognized, but why is it by 12-year-old girls? I mean, it just wasn't what we were expecting. No, it was exactly what we were expecting. We just wanted to be recognized as authors. So now I'm going to run this thing again, and I'm going to tell you what a few of you already knew, is the first guy is Jack Black at age 9 or 10.
Just last night, I was lost in the jungle with Pitfall Harry, surrounded by giant scorpions and man-eating crocodiles.
Well, Harry and I just grabbed the van, swung through the trees, and over the tar pits and found the jungle treasure. It was really neat.
If you haven't met Pitfall Harry, you're missing the year's most incredible video game adventure. Pitfall for the Atari 2600 and in television.
Since I met Pitfall Harry, no other man will do.
Pitfall, designed by David Crane for Activision.
So that's the end of my prepared comments. They're bringing up the house lights so that anybody have any questions on how things were done back then? Find a microphone.
So I have a question. Between this and A Boy and His Blob, it seemed like spelunking was sort of a theme. Was it that like Indiana Jones was sort of out in the media at the time as a big thing? Was it personal interest in caves or just sort of happened that way?
No particular interest in caves, but I was inspired by Raiders of the Lost Ark and such. And then once I did one, there's a lot of cool things you can do. I mean, as soon as you say, well, gee, I can run off one screen and I'm on a completely different screen, it's infinite. And so I have done a few. A Boy and His Blob was a lot of fun, too. Now, A Boy and His Blob was more than just the adventure. It was the premise of having a sidekick who was your toolbox. And I really liked that concept as far as gaming was concerned.
Thank you.
I know this may require an entire separate postmortem, but did you find any other additional kinds of tricks that you had to add on, given all the space concerns for Pitfall 2? Because it seemed like that was such a more massive game with all the balloons and everything like that.
Yes. Was there any additional technology involved in Pitfall 2? In fact, I started my career as a chip designer at National Semiconductor. I worked there for 2 years to fill out my engineering training because I hadn't had experience in certain areas, and I said, I'm just going to go take a job there and learn that stuff. And so by the time we came around to Pitfall 2, we had pretty much, we meaning the 200 maybe game designers doing 2600 work back then, had pretty much come to the limit of what we could do to that poor little chip. So I specified a custom integrated circuit that went in the ROM, and it gave me a little bit extra capability. It let me write kernels, which we describe those display code as. It allowed me to write those with more capability, take fewer cycles, therefore be able to do more. And it gave me 3-part harmonic music, which was also built into that chip. So Pitfall 2 is going to look a lot different than Pitfall 1, and I cheated. I put a chip in with the ROM.
I have a question. Okay.
Who's next?
Over here.
Over here.
So one thing that I think is pretty special about Pitfall is that it's got double the resolution of most Atari games. It's got a one-line kernel. And that gives you a remarkably small amount of time to get all your registers loaded up. Why didn't you just say, all these other games are doing these two-line kernels, and this will save me so much trouble with trying to fit all the clock cycles in? What made you choose the really hard route that not a lot of people were doing?
What made us choose the hard way? I wouldn't have been doing 2,600 games if I wanted to choose the easy way. There are some crazy things we've done, and I could spend hours up here telling you some of the craziest things. A one-line kernel was far from the craziest things that we would even think of doing. But it just looked better. I mean, come on. If I can make something that looks better, and eventually it'll play better as well, but I spent a lot of time on the displays. And the one-line kernel, this is a knowledgeable questioner here. When I showed you the tank game, the loop that was running in the tank game took 2 full scan lines to update everything. As a result, the vertical resolution of the pixels is 2 scan lines, because they don't get changed again until 2 later, and then 2 later, and then 2 later. And we just didn't consider that acceptable, and we started changing the registers every single scan line. And the tricks you had to pull were amazing. I mean, sometimes you would have to build a table that has the data in it so that you can suck data out of the table. Sometimes you had to write code in RAM, self-modifying code, and execute code in RAM because it ran 1 cycle quicker in RAM. We just did all those things and loved it.
Thank you.
More of a statement than anything else. During your talk, you've talked about the polynomial, which I always point as one of the genius moments in programming. The total level data, if I recall, was 50 bytes?
Something like that, yeah.
And it's much, when I try to explain to people, A, why they should buy Racing the Beam, and B, what that really is, if you say that you have 256 rooms in 50 bytes, that stands. And I wanted to thank you because I'm a historian, so I've seen a lot of your talks, and I know you've done this 1,000 times, but they take particularly good recordings here. And so I'm glad you did the 1,001 for us. So thanks a lot.
Thank you.
This isn't specifically for Pitfall, but I was wondering if you could tell me whether it's a coincidence or a conspiracy that I can plug my Genesis controller into a 2600 and have it work actually as you would intend it to.
I don't know. I mean, the 9-pin D connector that Atari put on their machine, was a standard. And I suppose I could see the Sega engineers saying, gee, this must be a standard. We should probably follow it. I don't know.
Hi, I came from Japan, and thank you for very great presentation. I am Japanese, and your presentation is very, very new for me and very impressive. And I love the title, Pitfall, because this title is very, very suitable for this game mechanism. So I think you named the Pitfall by yourself, but when did you name it?
Yeah, the question is, how did Pitfall get its name? And, of course, it is somewhat appropriate since you do fall in pits. The game was called Jungle Runner as a working title. And when you're playing or designing a game and you're spending 9 to 12 months developing these games and it has a working title, the working title really gets ingrained. It's really amazing that when you get to the naming of a game, every name that you brainstormed sounds so lame because, no, the game's Jungle Runner. I mean, that's what it is. And fortunately, we had some pretty good marketing people at Activision who just put their foot down and said, no, it's not. It's not Jungle Runner. But in the brainstorming sessions, they came up with things like Zulu Gold. And somebody said it sounded like some new drug. Amazon this, and how brainstorming sessions go. And I suggested Pitfall because I like puns, and it finally caught on, but it was very difficult to get away from Jungle Runner.
How about the character's name, Harry?
That's another good question. I just called him Pitfall Harry, and I've heard since then that there was some explorer who was named Harry or something, and I was accused of using that. But honestly, it just sounded good. Mm-hmm. I just called him Pitfall Harry.
Mm-hmm. Thanks so much.
Thanks.
Quick question about collision detection. I was interested in how you managed the collision, like when you were standing on the crocodile's heads. Was that purely just an understanding of like which pixel your player was actually standing on, like hard-coded, or was there?
Yes, the collisions were all software collisions. The Atari 2600 actually did have built-in hardware collision registers. If you had one of your one-dot objects touch an on pixel of the 8-bit object, there would be a flag set in a register that said these two things have touched, which is really nice. I mean, you could think about it. It's perfect. Pixel by pixel collision detection. Unfortunately, you shoot your missile at 2 pixels per frame, and it misses that pixel. So now you're saying, well, wait a minute. Now I have to loop through it twice. What do I have to do? You actually just gave up on the hardware collision detection, even though it was in there, all that cool hardware. And Pitfall Harry was standing on 3 or 4 pixels of the alligator's head, and so if the alligators were on the screen and Pitfall Harry was in those 4 pixels, I knew he had ground under him. And of course, if he was on those other pixels, he only had ground under him if the mouth was closed.
Hi, I think that Pitfall is like only one of the only game in that era that had like a angled perspective like that, and like from an artistic standpoint, that's pretty unique. Like, do you have background in art, or like why don't you think that a lot of the games, like especially on the NES, like didn't follow that kind of level of depth?
So why did Pitfall have a cutaway view and a sort of isometric display? It was just really the next step in evolution. I was trained in art. My mother is a fabulous artist. She made all of her children take watercolor classes and all that sort of thing. And I got to the end of painting a painting, and I said, I've spent 6 hours on this thing, and there's only one of them. And, now, of course, we would just publish it or something, and you can have thousands printed. But I liked the idea of being able to spend some time on something and then make 1 million of them. So I wasn't really into one-off art, but I did have some training. But really, it was just a matter of envisioning this side view world. I almost said side view scroller, but this was not a scroller. They came later. And if you're on a side view, you have a cutaway of the world, and you will have some perspective. So it wasn't... How can I say this? We were making new things every single day. I mean, everything we were doing had never been done before. So I can't look back and say, ooh, that was a great idea that I made it isometric and cutaway. It's just, if I'm going to have a view of a jungle, that's the view of the jungle I chose. Where are we?
I'm kind of young. All the Atari stuff was before my time, but I hear, people like you talk about it. It makes me really excited just hearing like all the crazy tricks you got to do back then. And I'm just curious, do you have any recommendations for just kind of a hobbyist programmer who just wants to dive into that and see what that was like?
Do I have any recommendations for a hobbyist programmer to dive into that specifically, the 2600?
Yeah, or something of that era.
Well, my first suggestion is called Stella.
Sorry?
Stella. Stella. Stella was the code name of the video chip in the Atari 2600, designed by Jay Miner, who has since passed, and Joe DeCure, who was also involved in making the hardware for the Atari 800 and the Amiga. These are talented folks. But Atari liked to have code names for their chip projects. And they asked Joe one day, name it. And he looked across his cubicle where his Stella brand bicycle was. And he said, we'll call it Stella. Well, Stella is a emulator for the 2600. And it's fabulous. The amount of work that went into that is 100 times more than my total amount of work that I put into every 2600 video games went into this emulator. You can play every single Atari 2600 game ever made on the emulator, and if you hit the little tilde key in the upper left-hand corner of your keyboard, it brings up an entire debugger that can single-step through these codes. So you can look at the code, you can run the code, you can analyze the code, and you can write your own code. So if you have any interest in the 2600, you should own Stella. You should own Racing the Beam. And you should download every 2600 game ever made, because remember, they're only like 4K bytes apiece. So the entire work in the history of 2600 games is about a megabyte.
Thank you.
Hi there. I'm a sound designer, and I'm curious how you designed the Tarzan sound, because it's a tricky thing.
Well, it's Johnny Weissmuller's Atari Yell, as close as the Atari 2600 could render it. It turns out that the frequencies that you can choose on that chip are not pure notes. They're non-chromatic. And so I used the square wave. That's why it buzzes a little bit instead of sounding like a pure tone. And I just chose the closest note I could. And when I first demonstrated that for people, I'd have people saying, what was that god-awful noise? They didn't recognize it as being Tarzan's yell, but I left it in there. There is a funny story going along with doing that is Gary Kitchen, another one of classic games creators, did a game called, it was Pressure Cooker, I think, and wanted to have a nice little ditty at the beginning, a musical ditty. So he hired a composer. So he might have hired like you. He might have said, you come in here, and I want you to write me a tune, a really catchy tune. And he took a marker, and he took a Casio keyboard, and he marked the notes that Atari could actually render within 1% of true notes. And they were just random keys on the Casio keyboard. So the guy came in all gung-ho, and Gary said, okay, now, those are the notes you can use. And you did a pretty darn good job. If you ever see Pressure Cooker, it has this little doo-doo-dee. I don't even remember what it is, but it was just a nice little ditty. And the guy, and just imagine the look you'd give somebody who said, I want a song, and these are the notes you can use. And there's only about 9 of them.
Yeah, that's true. There's an article by Karen Collins about that called The Terrible Twos. So for the actual design of the sound, you just did it by trial and error, I assume.
Yeah, and again, there were no tools, so I basically had to write the code that read a ROM table that said use this frequency divisor, plug this into the hardware, and use it for this many frames, and then switch to this and switch to this. So it basically was a ROM table being run through an algorithm.
Yeah, I'm doing similar sound design for the game I'm working on right now, which is Retro City, and so it's tricky. So I wanted to ask directly. Thanks.
Okay.
Hi. Your breakaway from Atari and the establishment of third-party development was a really crucial step for the industry, clearly. And I wondered what you thought about two things that are sometimes related to that now. Chris Crawford yesterday talked about the great crash of 83, 84, and how, in a way, you opened the floodgates for other people to make low-quality carts, where obviously you guys weren't making low-quality carts, but then other people were able to do that. And also, I think it was yesterday, Trip Hawkins said that the the recovery from that crash of Nintendo's move of controlling platforms to restore the industry has now become a problem and is happening again now in the social space. I wondered what you thought about these two things.
Well, for those of you who weren't even alive then, the video game business crashed in 1983. What happened was very simply what Activision did, as our questioner said, opened the floodgates. We were very successful, making money hand over fist, and people says, I can do that. And venture capitalists stepped up and started funding these companies to do just what we're doing. But when we were doing it, there were only about 10 people in the world who could do this, who knew how to do this. It was very left brain and right brain intensive. You had to be extremely technical and still be creative, and you had to figure out what's fun and all those things. And they were hiring high school kids who said, yeah, I can program a computer. And so the quality of the games really crashed. I mean, I'm talking about a time when there was no GDC. The equivalent of GDC was when the Activision game programmers and the Atari game programmers ran into each other at the food court at a local mall. I mean, that was it. So there wasn't the talent base necessary to do great games. So venture capitalists stepped up. They spent $2 million on this company, $2 million on that company. In one 6-month period, 30 companies showed up doing video games that weren't in the brochure at the last trade show. And we looked at each other and said, the crap they're putting out, they're not going to be in business a year from now. We were right. We didn't realize when we said that every one of them going out of business was going to completely destroy the market. And what happened there was people, they had a warehouse full of games and they go out of business. So some liquidator comes in, pays the bankruptcy trustee $3 a piece to buy them out of the warehouse, retails them or wholesales them for $4 and tells the retailer, you can sell these for $5 a piece. And those people who were alive for that era, you walked into a Toys R Us or a KB Toys and there was this barrel in front of the doors filled with 2,600 cartridges, just random 2,600 cartridges, $5 a piece, $5 a piece. So the kid tells dad, I want the latest Activision game under the Christmas tree. So they're about $40. Dad walks into KB Toys and says, wait a minute, I can buy 8 games for my $40. I'm going to be a hero. So in one Christmas, sales of new games went to 0. There were 20 million cartridges out there in those barrels that had to sell through first before anything we were doing could be sold as a new game. And it was pretty hard on the industry. As for coming out of it, yes, when we came out of it, Nintendo, the American video game industry was bloody. Nintendo came in and brought their NES. But they signed up developers and publishers to a very restrictive contract, and you had to sign that contract if you wanted to do anything for Nintendo. And then they controlled the business. And they got a little heavy-handed and caused other problems. So we go through cycles. I mean, we're going to go through more cycles.
I already had another question. You can go first.
Sure. When I think about the Activision games, one of the first things that always comes to mind is the classic covers and the iconic rainbow. And Pitfall in particular stood out for a couple reasons. One of them being it most closely resembled the actual game rather than some BS that just made you want to buy the game. And I was just wondering if you could tell us a little bit about the artist who did that. Was he in-house?
Well, no, it was another one of our founding principles. Atari at the time was doing highly stylized box art. And we basically went to our business people and I said, no, we're not going to do that. If you want, I want you to be able to look at the box and decide you want to buy this game, because you're not going to know until you get it home and plug it into the machine. So we insisted on absolute pixel identical art on the front cover. And our marketing people looked back and said, you're absolutely out of your mind. No, we're not going to do that. But we will put a precise screenshot on the back. And then on the front, we'll do some sort of an artistic rendering of the screenshot. And that's really where that came about. Another time I was in Jim Levy's office, the president we chose to run this company, us programmer guys. And he looked over at a shelf that had a bunch of Atari games on it. And he said, look at all those. He said, you can't even tell that those games are from the same company. And he had an eye for that. So if you ever stack all of your Activision boxes up side by side, the font's the same, the placement is the same, everything works like it's a family. And so it's really our insistence on having a game, real game image, and then the marketing people's artistic skill of making something like that looks a little better. Now, I've just been flagged that my time is up, but okay, good. We actually came out even. Thank you.